So, very good evening to one and all. I think I'm audible to you. So, very good evening to one and all. Thank you for your presence in our 30-day masterclass. I think I'm audible to you. If my voice is clear, means just put S in chat box. So, better thoughts. Very good evening. Jeevan, very good evening. So, if my voice is clear, means just put S in chat box. K7, very good evening. Thank you for your daily presence in this masterclass. So let's wait for a few minutes. So last class, yesterday we seen UART protocol design code. Today we are gonna see UART protocol verification code, like a SystemVerilog test bench architecture for UART protocol. Okay. So before going to that, I will show you one black diagram. So let's wait for a few minutes. So remaining people have to join. So Venkat, very good evening. Thank you for your presence. So Shankar Reddy, very good evening. Narayana Murthy, very good evening. Thank you for your daily presence. Yes, thank you for your valuable response in chat box. So today we are going to see UART protocol verification part. Last class we seen randomization and also UART design code, transmitter code and then receiver code. We are gonna do the loopback of UART protocol. Loopback is nothing but I am sending one data from transmitter to receiver. I am checking that whether it is received or not. So this is a loopback. So we'll see the verification code today. So and then thank you for your joining. Vamsi Krishna Reddy, very good evening. So Roshini, very good evening. So before going to that, so let's wait for a few minutes. I will start at sharp 7:05. I hope you people understand the UART protocol. What is start bit, what is data bit, and what is a stop bit. So start bit means 0, data bit means 8 bit of data bits, and then 1 stop bit. We can also give a parity bit for safety purpose, security purpose. So Steve Krishnan, very good evening. So and then I said no. If you the UART protocol while writing into Verilog means you have to calculate the clocks per bit by using the formula is input frequency divided by baud rate. If my input frequency is 50 MHz and then my baud rate is 9600 means if you divide this means you will get the some value. So based on that value our transmitted UART or received UART it works based on that particular clock pulses. Like if you receive it a 430 or 430 value means so at every 430 clock pulses only you can send the data from UART transmitter to UART receiver. Same thing UART receiver also works based on the clocks per bit at every 430 clock pulses. 430 clock pulses only. After a 430 clock pulses only the UART protocol will receive the data from UART transmitter. Okay. So I think I will start now. So this is a black diagram. So we written design code. We are gonna verify that. So there is a 2 devices, UART transmitter, UART receiver. So I'm going to send the data from transmitter to receiver. Okay. So and then in my test bench I will check. What I will check means whatever I send the data, if I send the if I send the data of 10, if I send the data of 10 from transmitter to receiver means I will check that if the receiver will receive the 10 value or not. If it is receives any other junk value means I have made mistake in my design code. So I will check the receiver. If I receive the value of 10 means okay, the receiver will works correctly and then transmitter will works correctly, everything fine, so your protocol working correctly. So this is how we can verify, this is how we are written the code, design code yesterday. Okay, so and then you can, I already said no, UART will send the bit by bit, one by one bit. Okay, so firstly it will send the start bit to receiver, and then it will send the data bit, and then it will send the data bit of second bit, and then it will send one by one of data bit, and then finally it will send stop bit. Okay, initially start bit 8 data bit, and then stop bit, it will send one by one bit. So in the while sending the data bit means, you can see here it's look like a memory. So this one memory, 8 bit of memory, it will store 8 bit of data. So okay, so at every 434 clock pulses, it will get the value of this first location, send into receiver, and then next after the 434 clock cycle, it will select from the second location, it will send into receiver. So same like receiver will receive the based on the clocks per bit, and then it will store into memory. From that memory we can decode that what is the value. So we are sending only binary, means after that you can decode the value. So if you receive the correct value means everything fine, our UART protocol working correctly. Okay, this is how we can check the UART protocol. Okay. And then before going to start the code part, I will explain about internship program. So if you guys are really interested in this master class, you can convert in this master class into 1 month of internship. So you will get these benefits of all 30 days recording session, all 30 days PPTs, and then you can also download the source code, and then you will receive your kind of project source codes, and then we will teach you how to run the code, and we will explain how to execute the code. Okay, so you will get the 4+ projects, and then you will get the internship confirmation letter from IETE, and then you will get the literally 6 months of LMS access, recorded sessions you will get access of up to 6 months, and then we are providing weekly sessions, tasks, and also. So and then you will get the internship report, academic internship report at end of 1 month of internship. So and then finally you will receive the internship certificate from IETE. So this is a link. Okay, you will get the internship program. Our regular fee is 4,999, but in this masterclass period we are going at a discounted fee of just 999. By using this link you can get the internship program. So after clicking the link you will receive this window, and you have to choose here advanced VLSI design and verification. Then only you will get this then only you will get the internship program. Okay, so and then this is a certificate you will receive at end of the 1 month of internship program. Okay, so can we start from the first? So Muhammad Tafiq. So I didn't start anything. So okay, I will currently I'm going to start the code part. Okay, so firstly we'll see the architecture of test bench, SystemVerilog test bench architecture. So you guys may know that this is a SystemVerilog test bench architecture. So firstly look this block, like firstly you have to look this diagram. There is a one top module. Okay, there is one top module. Inside the top module we having the 3 blocks, like a DUT, interface, program block. So here you can see here TB. The program block is known as a test bench block. Okay, this is a test bench block. This is an interface block. Here DUT is nothing but design under test. Here we are having the design module. Here we are having the program test bench module. Here we are having the interface. Okay, so this is a design code. The stimulus are gathered, randomized, are made from this block. Through the interface we are passing the stimulus from test bench to DUT, and also DUT will do its work. It will do its logic, and then it will compute some values, and then it will send back to the test bench via interface. So the stimulus are gathered, generated from this test bench, and then passed to our interface to DUT, and then DUT will do the computation process. The DUT will again send the output. It only send the output. So here in the test bench we are sending the input for DUT. Here from the DUT the DUT will send the outputs, okay, outputs to the test bench. In the test bench we having the scoreboard, okay, you can see here we having the scoreboard. It will compare, it will compare with the reference module. So we are having some reference, golden reference module. It is our expected output. If the DUT gives the required expected output, means if it is matches both the reference model and then DUT output, if both are matches, means our test case is positive. Why? Because of it is working correctly, okay. This is how the test bench architecture will work. So this is some simple top module. Inside the top module we have in the 3 blocks. We have to instance state. So we already know that instantiation is nothing but connecting the 2 modules. Here in the top module, this is one top module. Inside the top module we have to instance state 3 blocks, like test bench block, interface block, and then DUT block. So DUT is one kind of module. So interface is like a interface, it having own syntax, interface and interface. I will show you today. So and then program block. So like module, program also one block, like a program name, and then end program. So it having the separate syntax, like a kind of like a module. Program block also it having some syntax. So this is a top module. Inside that we have to instantiate these 3 blocks inside our top module. So if you want to simulate, means you have to simulate that top module, so automatically it will execute this kind of process, okay. Case 7 is sending data from after 4:43 clock. It will make more time to transfer or receive. So it won't make more time. Why? Because of, I will tell you, 50 minutes of clock. So if you assume like a 50 minutes of clock, it will count 5 core times in 1 second. So for example, Arduino board having the 50 minutes of clock. Assume like you having the Arduino board, it having the 50 minutes of crystal. It will give the 50 megahertz of clock frequency to controller. It means if you do counter operation by using the clock, means at every passage you will increase your count. In the first clock pulse you having 0, second passage you having the 1, and then third passage you having the 3. So it's same like it will do increment. It will do incrementing counting. So for example, if you having 50 megahertz of clock will do the counting of 5 crore counts for 1 second. So in the 1 second, within 1 second, the 50 megahertz of clock it will do counting of 5 crore times. Okay, it is not a it's not a small thing. It's a simple value, 5 crore clock pulses, 5 crore counts. So in the 1 second, the 50 megahertz of will give the 5 crore clock pulses. So we are just using 434 clock pulse only. It will do very fastly. So at every 434 clock pulse, so from 0 to 434, after the if it is reaches a 434 only, you can UART will send the data, 1 bit of data to receiver. So next, after the next 434 clock pulses, it will send the second bit. So same like assume 50 minutes of clock, it will count 5 crore times within 1 second. Okay, so assume like a 50 minutes of clock, 100 megahertz of clock, or 1 gigahertz of clock. So if you assume like a 1 gigahertz of clock, means it will count more than 5 crore, 10 crore, or 50 crores. Okay, it will give the more than 50 crore passages in 1 second. So it is very fast only. So you won't receive the data very lately. So so this is how the clock frequency is important for our chips. So based on the clock frequency only, we are using very fastly our chips. Okay, so clock frequency is very important. So can you explain receiver? So both the transmitter and receiver code are same only. So the main thing is, if you understand this block, means you can easily understand the receiver code. If you understand the transmitter code, if you understand this, means you can easily understand the receiver code. Why? Because of we are sending 1 by 1 bit based on the clocks per bit. So firstly we are sending start bit, and then we are sending the data bits from this memory. Same like here in this same like receiver, it will receive the firstly, it will always looking for start bit, and then that 8 data bits, and then it will looking for stop bit. okay. And then if you the receiver will receive the data from transmitter, and then it will remove the start bit and the stop bit, and then it will store only the 8 data bits, 8 data bits into this memory. So the transmitter will sending one by one bit, firstly start bit, 8 data bit, stop bit. So the receiver also will receive the same thing, like it will receive firstly start bit and then 8 bit of data, and then it will receive the stop bit. So after one transmitting of 8 bit one data, the receiver will remove the start bit and then remove and also remove the stop bit. So you having only 8 bit of the raw data, and then it will store into one memory. From the memory we can decode what is the value, so what is the data. This is how UART receiver will work. So for that we are having some state, like I will show you the receiver code. Same, like it having the same state, ideal state, start bit state, data bit state, stop bit, and then done state. Same, like it will receive the data at every 434 clock pulses based on the clock per bit, okay. So and then I will show you the I explain this. So I hope you guys understand this block diagram. So here in the program block, inside you having the test module, and the inside your test module you having the environment class. Environment class is nothing but it having collection of classes. So collection of classes is nothing but transaction is one kind of class, generator is also a class, driver is also one class, input pointer also one class, output pointer is also one class, scoreboard is also one class. Here you can see here we want to transfer the data from one class to another class. By using this mailbox, we can send the data from one class to another class. We already seen the code previous classes, how to use the mailbox, how to declare the mailbox syntax. So we already seen that, okay. So here we having the mailbox so to send the data from one class to another class. So and then the main thing is interface will make communication between these test bench, like this stimulus test bench module, and then it will make communication between this test bench module and DUT module, okay. It will make communication between this module and then this module, DUT module. So why? Because of DUT is static in nature, these are in dynamic in nature. Each and every classes are dynamic in nature. They are called packet n types, but here it will do pin type data transferring. So here it will do packet type data transferring. So we want to convert it. We want to convert this packet to pin to packet. So how we can convert means by using this interface we can convert. So it is very big process of verification. Why we are doing this big process means we can do easily randomization, we can do easily constraint, we can add the signal in the transaction. You won't add the each and every signal at every part of your code. If you want to add one signal in your code means you can just add here in the transaction class. You can add here. It will automatically affect all the classes. So I will show you that. So UART underscore trans, this is my transaction class. So here you can see here these are my UART protocol, UART DUT IO signals, input output signals. Also, okay, I'm going to randomize this signal and then I'm going to pass the inputs to DUT. So in the transaction class, this is named as transaction class. Here I am just declaring the IO signals, input and output signals, okay. So and then I will go to another class, generator class. So in the generator class it will do a randomization operation, okay. So in the generator class it will do randomization operation. So you can see here this is my you can trans, okay, UART underscore trans, this is my this class name, okay. This is my transaction class name, okay. I'm creating the handle for this class inside my generator class. So here this is my generator class, UART underscore gen means UART generator class. I'm creating the handle for UART transaction class inside my generation class. You can see here this is my transaction class name, and then this is my transaction handle name, object name. We can see here rand keyword. Rand keyword is used to, it is used for random. If you didn't given the rand keyword means you can't do randomization. So what randomization means, you can't do this operation, you can't do this randomize method. So if you want to randomize means you have to write rand keyword. So and then I am creating one mailbox here. So mailbox, this is a syntax for mailbox. It will useful for send the data, useful for send data data from generator to driver. Okay, here I am doing the randomization process. Why? Because of in the transaction class I am having the input and output signal. So in the driver class, in the generator class, I am going to randomize the transaction class. So I can do only randomize input data. Okay, I can do randomize for output signals. I can do only randomization only the input. Why? Because of we can do only input. We can do randomization for only input. If you do the randomization for output means it is logically wrong. So you have to randomize the input signals. Okay, so I'm going to randomize the input signals inside my generator class. So and then you have to write each and every class new function constructed. Why? Because of if you made, while before we have used a class like a class A, class B, parent class, child class, we are manually making the memory. We are manually allocating memory inside our initial begin block. So people may know that with the using of the object name like a handle name of class equal to new constructor. This is refers to allocating the memory for that class. But here we can't, there is another way of creating, there is another way of allocating memory for the class, means this is a way. So inside the class, if you create this new constructor, new function, means you can easily, it will allocate the memory for this generator class. Previously we are done with implicitly we are allocating the memory inside our simulation block, initial begin block, while in the top module. So people may know that a equal to new open bracket close bracket. Okay, this is a way of creating memory, allocating memory for the class object. But here this is a second way to allocating the memory for this class. Okay, new constructor. So here I am passing some arguments from the outside the class. So I will call this function from another, okay, from another function from another class or another module. So on the time I can pass the arguments. So arguments are, this is the my new function, new constructor arguments. Okay, so and then I am assigning into this my current class properties. So this keyword is refers to, it will receive the arguments from outside and then it will assign into my current class properties. How we can assign means by using this keyword. This is this keyword. By using this keyword we can assign the arguments to the current class properties. Okay, I hope you guys understand. So and then inside my class I am having one task here. The task name is main. So and then I am doing the repetition process, repeat block. So here you can see also repeat underscore count. Here I am made one signal. Here I am register one signal, internal signal for the class generator. The signal name is repeat count. So based on this repeat count, it will do repetition process. So you can see here dot randomization. It means I am doing randomization. If it is not doing randomization means it will throw an error. The fatal error is nothing but randomization failed. If it is not randomized means it will throw an error via the fatal, like this error, randomization failed. This is error only if the randomization is not happening. If it is happening means it will it will won't display anything. So and then you can see here, this is my mailbox name, generated to driver is my mailbox name. I am putting some data. I'm putting what data means, I am putting the trans is nothing but the UART transaction class handle name. So here I am doing randomization of the transaction class. So after randomization I am putting into my mailbox. Okay, so where I am putting from generator to driver mailbox. So if we having one mailbox, I am putting the randomized transaction class I am putting into mailbox. Okay, so in the driver I will receive that code. So in the driver, so this is my driver class. Okay, this is my driver class. In this driver class I will get the data from mailbox, and then I will send into DUT via interface. Okay, you can see here this is a UART driver class. So main thing is UART is a very important class. Why? Because of it will send the packet level data into pin level input for DUT. So you can see here driver are doing a packet level operation, DUT are pin level operation. So interface will make the bridge between the test bench and DUT. So it will, so you can't, so you can see here this is a static in nature, DUT are static in nature, classes are dynamic in nature. So directly you can't communicate between the static to dynamic type. So on that time you have to use virtual interface. Okay, so we already seen that in the polymorphism or encapsulation, virtual interface. Abstract class we are using the virtual interface. So this is an interface, so we can make the virtual interface based on this interface. So how we can make the virtual interface means by using the virtual keyword we can make the virtual interface. By using the virtual interface only we can send the data from driver to DUT. Here in the transaction class we have in the IO signals. Here I am doing the randomization. After randomization I am putting the data into mailbox in the mailbox. So in the driver class I am getting the data from mailbox, and then I will send the data to DUT by using the virtual interface. Okay, this is how it will works. So after that again it will DUT will do some work, and then again it will do convert the pin level to packet level conversion. Again it will given into input monitor. So but in my code I am giving the input from I am giving the DUT output to driver only. So I didn't write any input monitor output monitor. If you based on our logic, so I didn't write any code for input monitor output monitor. Why? Because of I am giving the output data to my driver. From the driver I am doing the scoreboard operation calculation. For a simple purpose I am just doing all these things inside my driver code. Okay, this is my driver logic. This is my driver class new constructor. So you can see here I'm having the reset task. It will do reset condition. This is my main task. So this is my main task here inside my so why I am creating main task at every classes means I will say end of the code. Why? Because of creating the same name task in the every class means you will get one benefit. I will tell you at later. Okay, I will show you the answer. So here in the main task I am having the one forward block. You can see here I am getting the data from the, you can see here generator driver is my mailbox name, get. So in the generator class I am putting into mailbox. Here I am getting from the mailbox this is my mailbox name, get, and then trans. So this is the data I am putting into mailbox. I am getting from the mailbox. This is the data. Trans means randomized transaction class handle name. Okay, so and then this is my display statements for my display condition. So and then I'm creating one virtual class. So you can see here this is my virtual class. So how you can make the virtual interface means, so firstly we have to learn about interface. So interface work is to make communication between this test bench block and then design block. Okay, so interface is kind of one module block. So I will show you the code of interface. What interface? You can see here this is my interface. Okay, this is my interface block. So this is my interface. It will start from interface, interface name, and then end interface. Same like module syntax. It start from interface, interface name, interface port list, and then end interface. Here this is my input interface, port list, input logic, clock and reset. Okay, so this is my signals here, RX TX. So this is my signals RX and then TX dot and then TX underscore data in, RX underscore data in. This is my design code signals. I have to register in my interface also. You can see here clocking blocks. So this is known as clocking blocks. So literally what is the purpose of this clocking block means it will give the direction. Why? Because of output of this test bench. So what is output? The input signals, the randomized inputs only. It act as a output of this test bench, and then it will given to input for DUT. So and then the output of DUT is input for this test bench. So it will give the direction of the flow, design like verification flow. The main thing is the output of this test bench block is given as a input for design code. Output of this test bench block is given as input for design code. So and then output for this DUT code will given as input for this test bench code. It's like a vice versa. Why? Because of DUT need randomized input. Okay, this test bench need computed output from DUT. So here we have to compare the reference model with the DUT output. Here DUT needed input from the test bench, randomized inputs from the test bench. So this is like a vice versa. So we have to give the directions. So where I give the direction means you can give the direction inside your interface block by using the clocking blocks. You can see here output RX and then output data TX underscore data in, output start and then input TX and then RX data out. So you can see here this is input for the test bench. Why? Because of RX underscore data underscore out. This is my output signal of receiver. So I am receiving output signal of my receiver. I am giving the input for my test bench. In the test bench I am having a scoreboard. In the scoreboard I am comparing the DUT output, and also DUT output is nothing but this signal this is a signal, it's a DUT output, and then compare with the reference model. So this is this input, this is computed output from DUT, from design code. It's giving as a input or input for test bench. Okay, so that's why by using this interface clocking blocks we can give the directions. So like this interface block is like act as a barrier between the like not kind of barrier, communication person between the test bench and DUT, like a broker, we can say as like a broker. So and then this is how we can create the clocking blocks direction inside my interface. So and then this is interface, and then we have to create the virtual interface. So inside my driver class I am creating one virtual interface. How I am creating virtual interface means, you can see here I am creating virtual interface. Okay, so you can see here I am using the virtual keyword. This is virtual keyword. This is my interface name. You can also see here this is my UART underscore INTF. This is my interface name. So in the driver code I'm using virtual keyword interface name, and then this is my handle name. So this is act like a virtual interface. By using the virtual interface I can easily assign the DUT outputs to packet level inputs like a test bench input, and then test bench output to design code input. Okay, so you can see here, by using the assume, so you can see only this line. So I'll just show you. So here I'm assigning, so tx underscore data in from the transaction class. I'm assigning into, I'm sending into tx underscore data underscore in, but a virtual interface. You can see here virtual interface. So it means from the transaction class I'm sending into DUT. It means that's one I'm sending into interface. Interface will send the data to DUT. So this is how it works. So I'm assigning. So this is how we can assign the data for we can assign the data from test bench to DUT by using the virtual keyword, virtual interface. So and then so if you understand, so it will take some time to explain one by one line. So I will explain main thing is test case passed or out. So you can see here, this is my logic, this is my main logic. So you can see you can just see this if condition. So virtual interface, like a virtual interface handle name dot rx underscore data underscore out. So this is my design code output signal. Okay, this is my design code receiver. It means receiver output signal is nothing but this only. Okay, this is my receiver design code. The output signal is rx underscore data underscore out. Okay, in my driver I'm comparing this I'm comparing that value with my data. So what is my data? So what I am given like what I am send the data from transmitter to receiver means that data. If the both are matches, so what I am sent and then what I am received. If both are matching means I can say RX pass, which means process my UART working perfectly, test case is passed. If it is not matching means there is an issue inside my design code. This is how we can verify the UART protocol. Okay, so and then if it is matches means transaction RX pass, and then if it is not matching, so you can see here I am using the equal symbol. If it is not matching means transaction RX fails. Okay, so and then this is my driver code. So and then this is my coverage. I will show you the upcoming classes, and then I will show you the environment class, UART environment class. This is my UART environment class. Here I want to instance state. I want to make the handles for all the classes like UART underscore gen, UART underscore driver, UART underscore con. So and then mailbox virtual event, and then all the mailbox I want to declare inside my environment. Why? Because of all these transaction class, generator class, driver class, scoreboard, all these are inside the environment. So I want to declare inside my environment, and then I have to call the all new function, and also I want to pass the arguments. So and then firstly I will call the pre-reset from the driver. So and then I will call the all main function. At the same time I will call the all main function are inside my classes. You can see here main task class. I will call the all main task. Okay, each and every class, like a transaction class. I will show you in the generator class. It having one main task. I am calling this task inside my environment class. Okay, so and then post test. So to get if I'm passing the number of transactions and kind of things. So and then I will run the another task. Inside that you can find a lot of tasks like a pre-test, test, post test, and then finish. So okay, So this is the environment, and then this environment are inside the program block. This is a program block. So why we are using program block means the program block are executed in the reactive region of SystemVerilog. So these module are initialized or executed in the active region, but these program block are executed in the reactive region. So I will tell you one by one. So what is the timing region of SystemVerilog in upcoming classes? Why? Because of once you know all the blocks like interface block, program block, module block, classes, if you know this all the block means, then only you can easily understand the SystemVerilog timing regions. So it having some timing regions, 17 regions. Based on the regions only it will execute the code. So this assume like till now take in your mind this program block are executed in the reactive region. Okay, so by using this by using the program block, we can reduce the race run condition. So there is a lot of things here. So race condition is nothing but at the same time I am assigning the two values for the particular signal. So if this is a race condition, so I am accessing the one signal with the two inputs. So I am giving the two inputs for the one signal. So this is a race condition. So to neglect that, we can use test bench for program block. Design code act as a module. So act as a design code uses the module block. Why? Because of while doing the simulation, the design code must be firstly initialized. So firstly initialized, then only we can pass a stimulus. If you pass the input firstly means you will get the race condition, or if you pass in the inputs, so like your test bench module and then design code module or both are working parallelly means there is a chance to you will get the race round condition. Firstly we have to start the design code to execute, and then we have to start the program test bench code. Then only you will get the sequence output and then you will get the correct data. You will get the correct execution flow. Otherwise you will get the race run condition. So here I am passing some stimulus for virtual interface, and then I am giving the repeat count here. So you can see here in the environment class I am having the handle of generator class. So this is a generator class handle name. So inside my generator class I'm having one signal repeat underscore count. It is an integer type. I'm giving that 10. It means it will do 10 times of repetition. That this signal are inside my driver class, are inside my generator class. Okay, this signal is inside my generator class. So it means I'm doing the 10 times of randomization. So this is the main advantage of the SystemVerilog testbench architecture. Why? Because of this signals are inside my class. Okay, generator class. So I am accessing from the another module, another program. So I am accessing from the another program, another module block. So this is one advantage of SystemVerilog. Okay, so and then I am calling the run task inside my environment class. So this is a simulation of the test bench initial begin. Okay, so and then this is how it works. This is the UART program test bench block, and then interface block already we seen. So DUT we already seen yesterday class. Okay, we completed this block, and then we will move into this top module. So inside the top module only we are having the three blocks: program block, interface block, and then DUT block. So and then I will show you the top module. So you can see the top module here. So this is a top module, virtual interface. This is a virtual UART interface. This is my program block module name. Program block name. This is my interface name. This is my UART top module name, design code module name. So here I'm toggling the clock. This clock only are given to test bench and also given to design code. So again reset equal to 1, So and then repeat, and then I'm giving the positive clock reset equal to 0. After the two clock cycle, I'm just reset. I'm just setting my reset off condition. So and then this is how it works. Okay, this is my top module. So this is my top module. So inside the top module we have in the program response block, interface block, duty block. So you can see here, these are the instantiation of the design code module, instantiation of UART interface, sorry, UART test bench program block. So this is instantiation of UART interface block, this all three things are inside my top module. So if I run this top module, means it will automatically work. So while running, so I'm going to use Costa Sim software to run this code. So for that you have to run you have to run this, you have to make one run.to file. Here you have to just a minute. So this is run.to file. You can see here a Verilog compilation underscore files. So I will show that file. This is my file, compilation underscore file. So this is one file, it having all the include files. This is my UART module file. This is RX. This is my UART RX code. This is my UART TS code. This is my UART transaction file, generator file. Why? Because of I'm in my working folder, I'm having these files. So I have to, so while writing the run.to file means, you have to add here file names. So what are the files you are going to simulate means, you have to add all the file here in the Verilog side, in the Verilog line. So Verilog means Verilog simulation, like for the Verilog files. So for simulation purpose, what are the files you need means, you have to add here. So I'm adding in this here only one file, compilation underscore files. So inside that file, compilation underscore file, I'm just using the tick include method. It's a system task, like a kind of thing. So I'm including all the files for my project, including inside my one file. So I'm just add this one file in my run.to. Okay, so and then in the vsim, so here in the vsim, you have to give your simulation, your test bench module name. So your test bench module name is nothing but top module name, your top file module name. This is my top file module name. And then this symbol is add wave -r star. This is refers to give the waveform output in the Costa Sim tool. Okay, so and then run -all means I'm giving the instruction to my tool to run all the operations. Okay, this is my run.to file. So I'm going to run. So how you have to going to run means, here in the terminal, here you can see, you open the terminal and then click new terminal, and then you just type vsim. So it will open it will open the tool at your current working directory. After that, inside that tool, so you can receive this window, Costa Sim window. Here you have to write like a do run.to. So just type do run.to. So if you click means, it will automatically do simulation. Okay, so I am receiving my output. So you can see here in the transcript, so I'm trying to maximize. This is my transcript. Okay, this is my transcript output. So you can see here, number of transaction already we seen in our code 0. I'm counting my transaction 0 1 2 3. So at every time I'm sending the data. So tx underscore data in, this is my transmitted data, which is sent to sent to receiver, like a receiver UART. So this is the data 34. Okay, and then exported data is 24 but obtained data is 48, so there is an error. So test RX is failed, so TX is passed. So I'm sending the data correctly, but receiver will receive the wrong value. So why? Because of, you can see here obtained data is 48. So in my code I will show you that part. I'm comparing. You can see here I'm just giving them, I'm just receiving the data from the receiver. Obtained data is a UART, you can see here RS underscore data out. So this is the output of receiver code. Okay, so my receiver will receive the data of 48, but my data which is sent by the transmitter is 34, but I received 48, so RX failed. So this means receiver code is failed. So I'm doing another test case. So this is my transaction 1. You can see here my data TX underscore data in is 86, but I am received data is 81, export data is 81, so test case is passed. Here also 9, so export data is 9, so obtained data is also 9, so test case RX is also passed. 63, so export data is 63, so obtained data is also 63, so RX is passed. So this is how we can check the UART verification code by using SystemVerilog. Okay, so and then I will show you the waveform window. So you can see here from the tool in the Costa-Sim, you can see this waveform output. Okay, so here in the waveform window, you can notice here there is a small arrow mark here. You can see here from outside of the diamond, like this diamond symbol. This symbol is refers to test bench output. Okay, you can say this symbol is refers to DUT output, like a DUT output signal. So and then so my TX data, and then we want to check the TX and RX data. So where we have to check means, you can see here, these are the signals we are using inside my design code. Like these are signals: clock, reset, virtual interface, data in, start bit, stop bit, and then receiver side, transmitter side. So and then these are the signals we are using in our code. So there are a lot of signals. These are the waveform outputs. So if you zoom it means you can see the values. You can see the each and every bit. Okay, each and every bit of your each and every bit of your bracket, so your values, your protocol values of 8 bit of data. TX data is 86. Just a minute. TX data is 86, and then this is my 86 my TX. You can see here I am receiving here I'm having the 86. Okay, so TX, I'm sending the 86 data to my receiver. So in the, you have to choose the receiver output. So where you can find means TX data. So here I am receiving the output like a 49, 41, 01, 81. So and then if you scroll down to here means you will receive the 86 also, 86, 63. So and then 4D, 0D, 61, 65. These are my output of receiver side. Okay, this is how we can check the results by using the waveform, and also by using the transcript. So while checking the output inside the waveform, it is hard thing. So but in the transcript we can easily check the output by comparing the results, by comparing with the reference module. So this is how we can use the Costa-Sim for verification. So I will show you the clock toggling. Okay, so I'm just zooming in. So this is my clock signal. Okay, clock DUT. I'm just zooming in. So it will count 434 clock cycle. So from the first 434 clock cycle only it will, after the first 434 clock cycle only it will send the first bit of data. So if you count this clock means this is a clocks, one passage to another passage is a one passage is called, one passage to another passage is known as one clock. So 434 clock cycles, after these 434 clock cycles only I can send one data, okay, by using the UART protocol. This is how we can use UART protocol. So if you guys any doubt means you can ask now. So if you join the internship program, you will get the code, and also you will get the weekly live sessions for your doubt clearing, and also you will get the internship certificate also. So and then if you don't want means you can use the internship YouTube membership. You can join your YouTube membership, you can easily rewatch this video. So and then this is for today. You guys have any doubt means you can ask now. So it is a complex thing only, so very difficult to understand this code. As you are fresher for this SystemVerilog code means it's very difficult to understand. So just try the simple codes, like yesterday we seen the code like randomization. So just try this kind of code, like class properties, like I'm having the class properties, and then I'm doing randomization of this class. If you daily do this practice means you can easily understand the protocol kind of code. Okay, this is my class name, class handle name. Here I'm allocating the class memory, allocating the memory for the class. Okay, and then here I'm doing the randomization. By here I'm using the repeat of 10. Okay, which will do 10 times of randomization. So you can see here I'm already said no. Inside that I am having one function, new constructor. So in the code also you can see here it having the new constructor function. So allocating memory you can use two ways. You can also create the new constructor inside your class means it will automatically create the memory, or else you can create the memory by using this method. Both are only for creating the or allocating the memory for the class. So okay guys, thank you for listening. We'll see tomorrow with RAM code. We'll see the topic of RAM. So I think today I have to take the RAM class, but due to time constraint it will postpone to tomorrow. Tomorrow we'll see the single port RAM, double port RAM, how the RAM memory it works, how the addresses are very useful for RAM, so how we can increment decrement in the RAM memory locations. So we'll try to write the code in SystemVerilog tomorrow session. So thank you guys, thank you for listening. So we'll see tomorrow. Thank you.